Zero error. Measuring instruments have different types of errors. All errors can divide into three groups: gross errors, random errors, and systematic errors. There are three systematic errors: observational errors, environmental errors, and instrumental errors. Zeroth errors are kind of instrumental error. The main error of Vernier caliper is zeroth error. Before using the instrument, we must get it to the zeroth position. When static and moving jaws touching each other, vernier 0 must coincide with main scale 0. But if the instrument has a zero error, situation will be different. If you want to find the error, there are few steps. First of all, you must find the value type. There are two kinds of zero errors. They are positive zero errors and negative zero errors. After that, you must find the coincide vernier scale value. Then multiply it from the least count. To get the error, you must get the coincide vernier value and multiply it from the least count. If you want to know more about the least count, link in the description. Positive zero errors. In this case, the vernier scale 0 stops at the right side of the main scale 0. Because dynamic elements of vernier caliper cannot move to zeroth position. When we move vernier scale to left side towards main scale 0, vernier 0 stops before touching the main scale 0. This is positive zero error. It means when static jaws and dynamic jaws are touching, micrometer gauge displays a positive value. What is the value of this caliper error? You can see the vernier 16th mark coincide with a main scale value. It indicates as 8th mark. But actually, it is 16th mark. The least count equals to 0.05 millimeters. If you want to know how to calculate the least count, you can go through the above card link. Error is positive 0.8 millimeters. If we get a reading from this kind of caliper, we must reduce the error to get the real value. When error is positive and refinement is negative. There are some reasons for this issue. The main reason is smear something between jaws. As examples: corrosion, rust, and dirt rubbish. Other reason is dilatate jaws due to high temperature. Negative zero error. In this case, the vernier scale 0 moving more than the coincide position with main scale 0. When we move vernier scale to left side towards static jaws, vernier 0 stops after touching the main scale 0. This is negative zero error. It means when static and moving jaws are touching, vernier caliper displays a negative value. What is the value of this caliper error? You can see the vernier 10th mark coincide with a main scale value. The least count equals to 0.05 millimeters. Error is minus 0.5 millimeters. If we get a reading from this kind of caliper, we must add the error to get the real value. There are some reasons for this issue. The main reason is wear and tear of anvil and spindle. Other reason is contraction or compression due to low temperature. You have an example question. This is an actual vernier caliper. You can calculate the least count, zero error, and get the reading. After that, correct the error. This is the equation of the real measurement. Real value equals Vernier reading plus or minus 0 error. If the error is negative, add the error. Error is positive, subtract the error. Vernier reading equals main scale value plus Vernier scale value. Then the real value equals main scale value plus Vernier scale value plus 0 error. When touch the moving and stationary jaws, you can see the Vernier number 9 mark is touching with a main scale value. Vernier 0 is at left side to the main scale 0. So that this is negative 0 error. When we solve a negative 0 question, we must read the touching value from the right side. This is 0. This is 1, and this is 2. Then you can see the Vernier second part coincide with a main scale value. The error equals to minus 2 multiply 0.05 millimeters. It is minus 0.1 millimeters. This is the reading. Vernier 0 passes the main scale 52 millimeters value. Then the main scale reading is 52 millimeters. You can see the Vernier 6th mark coincide with a main scale value. But remember, this is 12th mark. You must consider large marks as well as short marks. Then the Vernier reading is 12 multiply 0.05 millimeters. Caliper reading value is 52.6 millimeters. After the correction, real value is 52.7 millimeters. Because this is a problem of negative 0 error. To correction, add the error to the reading value.